In this video, we will discuss about Unit 3 Calculus, important questions and answers. Using Rolle's theorem, show that g of x equals to 8x cube minus 6x square minus 2x plus 1 has 0 between 0 and 1. First step we need to find out is f of x is equals to 8x cube minus 6x square minus 2x plus 1 is continuous in 0, 1. Now f dash of x is equals to 24x square minus 12x minus 2. Therefore, f of x is differentiable function in 0, 1. Now f of 0 is equals to 8 into 0 cube minus 6 into 0 square plus 2 into 0 plus 1, which is equals to 1. Now substitute f of 1 equals to 8 into 1 cube minus 6 into 1 cube plus 2 into 1 plus 1. Here is 8 minus 6 plus 2 and plus 1, its value will be 1. Therefore, f of 0 equals to, f of 0 is equals to f of 1 by Rolle's theorem. F dash of c equals to 0. 24 into c square minus 12c minus 2 equals to 0. Therefore, c is equals to 3 plus or minus root 21 by 12, which is equals to 3 plus root 21 by 12 and 3 minus root 21 by 12. The values are 0.635 and the other value is minus 0.131. Therefore, c is equals to 0.635 0 to 1. Therefore, the Rolle's theorem is verified. Rolle's theorem is verified. Verify Rolle's theorem for the function f of x equals to equal 1 minus x sin x. F of x is equals to e power x sin x is continuous in 0, 5. F dash of x is equals to sin x into e power minus x minus 1 plus e power minus x into cos x is equals to e power minus x into cos x minus sin x. Therefore, f of x is differentiable function in 0 comma pi. Now f of 0 is equals to e power 0 sin 0 is equals to 0. F of pi is equals to e power minus pi sin pi. Its value is 0. Therefore, f of 0 is equals to f of pi by Rolle's theorem f dash of c is equals to 0. Therefore, e power minus c cos c minus sin c is equals to 0. 1 is e power minus c is equals to 0 and cos c minus sin c equals to 0. Cos c is equals to sin c. Therefore, c is equals to pi by 4. 0 comma 4. If a less than b, prove that b minus a by 1 plus b square must be less than tan inverse of b minus tan inverse of a less than b minus a by 1 plus a square. Using Lagrange's mean value theorem, deduce the following. Now let f of x equals to tan inverse of x. Let f of x is equals to tan inverse of x in a comma b. Therefore, f dash of x is equals to 1 by 1 plus x square. F dash of c is equals to 1 by 1 plus c square. By Lagrange's mean value theorem, f dash of c equals to f of b by f of b minus f of a by b minus a. Therefore, since f of b is equals to tan inverse of b, f of a is equals to tan inverse of a. Therefore, f dash of c is equals to tan inverse b minus tan inverse a by b minus a, which is equals to 1 by 1 plus c square equals to tan inverse b minus tan inverse a by b minus a. This is equation number 1. We know that a is less than b. Therefore, c is ab. Then a less than c less than b. Squaring on both sides. A square must be less than c square, less than b square. add 1 plus a square less than 1 plus c square less than 1 plus b square. Now from 1, now reciprocal 1 by 1 plus a square greater than 1 by 1 plus c square, then 1 by 1 plus b square from equation 1. From equation 1, 1 by 1 plus c square can be written as 1 by 1 plus a square greater than tan inverse b minus tan inverse a by b minus a greater than 1 by 1 plus b square. Multiply with b minus a on all sides. B minus a by 1 plus a square greater than tan inverse b minus tan inverse a greater than b minus a by 1 plus b square. Now we can write the same term as b minus a by 1 plus b square is less than tan inverse b minus tan inverse a less than b minus a by 1 plus a square. Hence, we know that now from the above equation a is equals to 1 and b equals to 4 by 3. Its value is 4 by 3 minus 1 by 1 plus 4 by 3 whole square less than tan inverse of 4 by 3 minus tan inverse of 1 less than 4 by 3 minus 1 by 1 plus 1 square. It is 4 by 3 minus 1 is 1 by 3 by 25 by 9 is less than tan inverse 4 by 3. Tan inverse of 1 is pi by 4 less than 1 by 3 by 2. Its value is 3 by 25 is less than tan inverse of 4 by 3 minus pi by 4 is that 1 by 6. Adding pi by 4 on both sides, pi by 4 plus 3 by 25 is less than tan inverse of 4 by 3 less than pi by 4 plus 1 by 6. We know that now a is equals to 1 and b is equals to 2. Then 2 minus 1 by 1 plus 2 square less than tan inverse of 2 minus tan inverse of 1 less than 2 minus 1 by 1 plus 1 square, which is 1 by 5 less than tan inverse of 2 minus tan inverse of 1 is pi by 4 is less than 1 by 2. Adding pi by 4 both sides, pi by 4 plus 1 by 5 is less than tan inverse of 2 is less than pi by 4 plus 1 by 2. LCM 5 pi by plus 4 by 20 less than tan inverse of 2 less than 2 pi plus 2 by 4. Prove that pi by 3 minus 1 by 5 root 3 greater than cos inverse of 3 by 5 greater than pi by 3 minus 1 by 8. Let f of x is equals to cos inverse of x a comma b. F dash of x is equals to minus 1 by under root 1 minus x square, and f dash of c is equals to minus 1 by under root of 1 minus c square. Then by Lagrange's mean value theorem, f dash of c is equals to f of b minus f of a by b minus a. Since the value of f of b is cos inverse b minus cos inverse a by b minus a. This is equation number 1. This is f dash of c. We know that a less than b, it implies c is in between a comma b. Then a is less than c less than b. Squaring on both sides, a square less than c square less than b square. Now multiply with minus 1 or changing the signs, minus a square greater than minus c square greater than minus b square. Now adding 1 to this one, 1 minus a square greater than 1 minus c square greater than 1 minus. Now first of all here we are squaring, here we are multiply with minus 1, here adding 1. Now here if you are reciprocal, now we are making square root 1 minus a square greater than under root of 1 minus a square under root of 1 minus b square. Now making reciprocal 1 by under root of 1 minus a square less than 1 by under root of 1 minus c square less than 1 by under root of 1 minus b square. Now multiply with minus 1 again, minus 1 by under root of 1 minus a square greater than minus 1 by under root of 1 minus c square greater than minus 1 by under root of minus b square. Now in the previous, the value of f dash of c is equals to minus 1 by under root of 1 minus c square. Now so you can substitute the value of f dash of c as, instead of minus 1 by 1 by c square, from equation 1 we can write 1 by under root of 1 minus a square is greater than cos inverse b minus cos inverse a by b minus a greater than minus 1 by under root of 1 minus b square. The equation is minus b minus a by under root of 1 minus a square greater than cos inverse b minus cos inverse a greater than minus b minus a by under root of 1 minus b square. Let a equals to 1 by 2 and b is equals to 3 by 5. This equation will be minus 3 by 5 minus 1 by 2 divided by under root of 1 minus 1 by 4 greater than cos inverse 3 by 5 minus cos inverse 1 by 2 greater than minus of 3 by 5 minus 1 by 2 by under root of 1 minus b square. B square is 3 by 5 whole square is 9 by 25. Now we can write this equation as 1 by 2 minus 3 by 5 divided by root 3 by 4 greater than cos inverse of 3 by 5. Cos inverse of 1 by 2 is pi by 3 greater than 1 by 2 minus 3 by 5 divided by under root of 16 by 25. Again, this equation can be solved as taking LCM is 10. 5 minus 6 by root 3 by 2 greater than cos inverse of 3 by 5 minus pi by 3 greater than here also 5 minus 6 by 10 by root of 16 by 25 is 4 by 5. Here that is minus 1 by 10 into 2 by root 3 greater than cos inverse 3 by 5 minus pi by 3 greater than minus 1 by 10 into 5 by 4. Here this value is minus 1 by 5 root 3 greater than cos inverse 3 by 5 minus pi by 3 greater than minus 1 by 8. Now adding pi by 3 on both sides, pi by 3 minus 1 by 5 root 3 greater than cos inverse of 3 by 5 greater than pi by 3 minus 1 by 8. F of x is given. F of x equals to log x in 1 comma e. F dash of x is equals to 1 by x. F dash of c is equals to 1 by c by Lagrange's mean value theorem. F dash of c equals to f of b by minus f of b minus f of a by b minus a. F of b is equals to log e. This is equals to 1. F of a equals to log e1. is equals to 0, since therefore f dash of c is equals to 1 minus 0 by e minus 1. Now from previous, f dash of c is equals to 1 by c. 1 by c equals to 1 by e minus 1. Therefore c is equals to e minus 1. 1 less than e, c to 1 comma e, then 1 less than c less than e. From above, 1 is less than e minus 1 less than e. Hence, prove. Thank you for watching. Please like, share and subscribe if you like.